Hi everyone, I'm going to go over the Unit 1 study guide for Algebra 2. So I'm just going to solve each problem. If you have questions, make sure you put stars by them. You don't have to watch this whole video if you don't want to. If you have a specific problem you want me to do, just fast forward so you can find it, because I'm going to just go in chronological order. So number one, it's an absolute value equation, so I have to set up my two equations. 4x minus 1 equals 5x, and then come over here and do 4x minus 1 equals negative 5x. So now I'm just going to solve. I'm going to subtract, I'm going to solve my left equation first. I'm going to subtract 4x and get x equals negative 1. That's one solution. And then I'm going to add 5x to the other side to get 9x, and at the same time I'm going to add 1 to the other side, and then x equals 1 over 9. Circle. Before you move to your next problem though, you always want to make sure that you don't have any extraneous solutions. So I'm going to take each answer and I'm going to plug it into the problem and see if it holds. You always plug it into the original equation. So I'm going to do 4 times negative 1 minus 1. Does that equal 5 times negative 1? If I automatically solve the right side, I get negative 5. Is there any way on this left side over here that I'm even going to get a negative answer? No, because it's an absolute value sign. So I already know 4 times negative 1 is negative 4, and then minus 1 is negative 5, but then when I do the absolute value of it, that doesn't equal this. So x equals negative 1 is not a solution. It's be an extraneous solution. If I come over and do the second solution, I would get 4 times 1 over 9 minus 1 equals 5 times 1 over 9. Honestly, this is where in class I taught you the stow button on the calculator. I would personally store 1 over 9 in my calculator, so I would type in parentheses 1/9. And then I'd press the stow button and press X and hit enter. And then I would just type in 4x minus 1. Math, enter, enter. I get 5/9. And then on the right side, 5 times 1/9 is 5/9. So yes, that matches. So my only solution on number 1 is 1/9. Not negative 1. So let's now go down to number 2. Oh no, this is not erasing. Let's see if I can erase it. Hold on one second. Let's see. So I can erase it. Alright. So let's go to number 2. I did a really great job erasing. I don't know why this is not working. Let's see. Next one is an inequality. Remember, when your inequality is grouped like this, it means it's an and statement, which means your graph, when you graph your inequality, is going to be a intersection. So everything I do on one side, I do on the both. So I'm going to subtract 4 on both sides. So I get negative 7 is less than 2x over 5 is less than or equal to 6. So I'm not going to multiply the whole thing by 5 to get rid of that denominator. So everybody gets multiplied by 5. I get negative 35 is less than 2x is less than or equal to 30. So now I'm going to divide everybody by 2, and then I'm going to show my work. So negative 35 over 2 is less than x, which is less than or equal to 15. So if I go ahead and I graph this, negative 35 over 2 is approximately negative 17.5. So here's 0, here's 15, here's negative 17, and negative 18. On your test, hopefully you would know to make a prettier inequality graph than this, but for purposes of time, I'm just going to graph it like this. Positive 15 and negative 17.5. Oops, that's an open dot. And I draw the intersection between them. If I wanted to state the interval notation, I would do, it's a parenthesis, negative 35 over 2, comma, 15, and then it's a staple. This thing does not like me. Let's see if I can erase. Okay, so I'm just going to have to erase every problem. Yay, get some nice muscles here. Alright, let's do number 3. Number 3 is an absolute value inequality. So I'm going to add, in order to set up my inequality, I have to get the absolute value sign by itself. So I'm going to add 2 to the other side first. So I have the absolute value of 3x plus 1 is less than or equal to 10 minus 2x. So now I'm going to set up my 2 equations. I have 3x plus 1 is less than or equal to 10 minus 2x, and 3x plus 1 is greater than or equal to negative 10 plus 2x. Alright, great. Now I'm going to solve. On my left equation, I'm going to do first, I'm going to add 2x to the other side. I get 5x, and at the same time I'm going to subtract 1 and get 9. So x is less than or equal to 9 over 5. On the other one, I am going to subtract 1, I get negative 11. Subtract 2x, I get x. So now I have 2 solutions. I'm going to go ahead and graph them. Okay, so if we go ahead and we graph this, negative 11 is over here, and 9 divided by 5 is 1.8. So I'm, again, just making my number line the best that I can. Negative 11 is a closed dot. 9 over 5, which is 1.8, is another closed dot, and it's intersecting between them. I also know that this inequality is going to be an and statement because this symbol right here is less than. And remember, when it's less than means and, great or than means or. So if I state my interval notation, I have negative 11 with a bracket, comma, 9 over 5. If you write 9 over 5 as 1.8, that's awesome. I'll give you full credit for that one as well. So let's keep going. I'm going to go ahead and erase all of this. And I wish I knew how to make this easier for me to erase all this, but that's cool. I'll just erase it. Worst case scenario, if I'm going too fast, just make sure you're pausing this video and we can keep going. So now we're going to go ahead and do number 4, which is up this way. Number 4. So let's check out number 4. So I got to get my inequality sign by itself. I'm sorry, not my inequality sign, my absolute value sign by itself. So I'm going to subtract 2 first because it's plus 2. So I'm going to subtract 2 and I get 10. And then I have to divide by negative 2, so I get negative 5. And when I divide by negative 2, my sign flips. Now notice we're used to this absolute value sign being on the left. So just to make my life easier, I'm going to put it on the left. Do I have to? No. But when you put it on the left, remember your sign flips. So I'm going to have 2 equations. X minus 3 is less than negative 5. And x minus 3, which is greater than positive 5. So I have x is less than negative 2. That's one solution. And I have x is greater than 8, which is another solution. So if I go ahead and I graph it, again, I'm graphing mine nice and sweet. Hopefully yours looks a little bit prettier than mine. But my interval notation would be negative infinity to negative 2, union 8 to infinity. So hopefully you're okay with that. Let's keep going. Let's see if I can figure out how to move these without having to erase it all. Maybe not. Let's see. Nope. Doesn't like me still. Well, let's do number 5. Number 5. It is a less than compound inequality. So this would be an and statement. So I'm going to add 4 to both sides. So I have negative 14 is less than negative 4x, which is less than negative 11. So now I'm going to divide by negative 4 on every single term. So I have 7 over 2 is greater than x, which is greater than 11 over 4. Remember, in order for it to be an and inequality, it has to be less than x less than. Whenever it's greater than x greater than, you cannot do that, which would mean this is no solution. So let's look at the next one. Number 6. So I see the word or, so let's go ahead and solve this. I'm going to add 3 to both sides. So I have 4x is greater than 12 and x is greater than 3. And over here I'm going to subtract 10. So I have negative 3x is greater than or equal to negative 18. And then I'm going to divide by negative 3, so my sign's going to flip, and I'm left with 6. X is less than or equal to 6. So I'm going to go ahead and I'm going to graph this. And I'm going to graph 1, 2, 3, 4, 5, 6. So 3 is open, it's going that way. 6 is closed, it's going that way. So the word or is the whole thing. It's the intersection. It's the entire picture. So it's going all the way to the left forever, and it's going all the way to the right forever. So in reality, I can actually draw this better, and I can literally just do this because it's going in either direction forever, which would mean it's all real solution. If I were to write my interval notation, it'd be negative infinity to positive infinity. So let's now check out what number 7 says. Number 7, find the domain. So the domain, I want it in set builder notation and interval notation. I personally find interval notation is easier, so I'm going to do that first and then go from there. So interval notation, all the way to the left, that's an arrow, and all the way to the right, that's an arrow. So my interval notation is negative infinity to positive infinity. My set builder notation is all my values of x, that are x. If I do my range, it's my lowest value, which is an arrow, to my highest value, which is another arrow. So interval notation, negative infinity to positive infinity. So if I do the interval notation, it's all my values of y such that y. Sorry, my squiggly braces look a little bit of a mess, but that's all right. So relative or local maximum. So relative and local mean the exact same thing. So I'm just looking for any maximum, so any hill in my problem. So I notice there's a hill right there. So that ordered pair would be 1, 2. And my local or relative minimum is right there, which would be -1, -2. If I do my absolute maximum, the highest point this ever gets, well, that's an arrow. I don't know where that's going. That's going on forever. It's an unknown value. It's indefinite. So my absolute maximum would just be none. All right, so let's check out number 8. Find the domain, interval notation. So when I'm looking at the domain on this problem, all the way to the left, let me do that in a prettier color, is red. And then notice here is a closed dot, but it jumps all the way up here, which is an open dot, which is fine, which means it's still a function, so that's still included. And then I'm going to keep going. That's still included. And then I'm going to keep going, which is an arrow. So really my domain is negative infinity to infinity, because an open dot and a closed dot just make a closed dot. So that would just be a filled location for my domain. For my range, it's a little bit different. My range, let's see if I can erase this. My range, so I first start here at -2, but then I jump from 0 to an arrow, which goes on forever. So I have -2 union 0 to infinity, because I have that nice jump, so I have to make sure I include it. Increasing intervals. So I want to know everywhere this picture is increasing. So highlight increasing, positive slopes. And then I'm going to go ahead and highlight decreasing. And I'm also going to highlight constants so we see it. So increasing is yellow. Increasing and decreasing and constant, we always look at the x values. So my increasing values are 0 to infinity, because I start at 0 and then I go to infinity. My decreasing values, go to red, -3 to 0. And my constant values, well, that's an arrow, so that's negative infinity on the x-intercept to -3. Is the following continuous or discontinuous? If discontinuous, describe the type of discontinuity. So this picture would be discontinuous because it is not a continuous flow in a pattern of a graph. There's breaks in it. So this graph would be discontinuous, and the type of discontinuity is that there are jumps. You could probably also argue that there are holes in the picture as well, but jumps, that's the most common one. All right, let's look at number 9. It says type the following functions in your calculator and determine the end behavior. So I'm going to see if this is going to work. Let me see if I can open up a camera. Let's see. So here, hopefully you're able to see my calculator, and I'm going to scoot it over down so I can see the equation. So I'm going to clear out my screen, and I'm going to hit y equals, clear that out, and I'm going to type in x to the 4th power, hit the right arrow, minus 5x to the 3rd power plus 4x squared plus 7x plus 1. I'm now going to press zoom 6 so we can see it, and it takes a while for it to graph. Awesome. So end behavior. As x approaches negative infinity, where is it going? And as x approaches positive infinity. So negative infinity is all the way over here. It's going to negative infinity on my x values. So what's happening to my y values? Well, it's just staying in positive infinity. What about when I go all the way to the right? Well, that's still positive infinity. So for number 9, as x approaches negative infinity, y is going to positive infinity, and when x is going to positive infinity, y is going to positive infinity. So now in my calculator, I'm going to clear out, and I'm going to type in number 10, 1 minus x to the 6th power, type in zoom 6, wait for it to graph. Notice as x is going to negative infinity and positive infinity, what's happening to y? Well, they're both going to negative infinity. So I can hopefully x out of this. Let's see if I can figure out how. Maybe just move it over there. And then we can write down. So we can say as x goes to negative infinity, f of x goes to positive infinity. And as x goes to infinity, f of x goes to infinity. Same thing with number 10. As x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to negative infinity. All right, so let's check out number 11 through 13. It says determine the inverses of the following functions, then determine if the inverses are functions. So for number 11, I'm just going to switch all my x values, 7, negative 5, negative 8, negative 6, negative 2, 1, 3, 10. So is the inverse a function? Yes. Why? No x values repeat. Let's go ahead and do number 12. If I just write it in my ordered pairs, it's going to be 2, 1, 3, 2, negative 2, 4, and 1, negative 3. Are those inverses of each other? 2, 3, negative 2, 1. Yes, none of the x values repeat. If I come and do number 13, I personally would write down each of the ordered pairs on this graph. So I would write down 0, 2, and 1, 1, and 2, 0, and 3, negative 1, and 0, 4, 0, and 5, 1, and 6, 2. I'm not going to plot all the inverses of these, so I'm just going to flip. So instead of 0, 2, it's going to be 2, 0. Plot a point. Instead of 1, 1, it's going to be 1, 1. Instead of 2, 0, it's going to be 0, 2. Instead of 3, negative 1, it's going to be negative 1, 3. Instead of 4, 0, it's going to be 0, 4. Instead of 5, 1, it's going to be 1, 5. Instead of 6, 2, it's going to be 2, 6. And if I connect my blue dots, I get my inverse function. Look at my blue graph. Is my blue graph a function? No. It fails the vertical line test. Notice if I were to erase this, if I were to just look at an original function and want to know if the inverse is going to be a function or not, I would use the horizontal line test. So notice the horizontal line test fails, which is why the inverse is not a function. It says let's check these ones out. It says given the following equation, determine its inverse. So in order to determine its inverse, what do? Well, I have to flip x and y and then get y by itself. So I'm going to put x, let me not write in highlighter. Put x where y is, put y where x is. Now solve for y. Subtract 8 on both sides, so I have x minus 8 equals 1/2 y. Multiply the whole thing by 2. 2x minus 16 equals y. This is the inverse equation. If I look at number 15, change x with y and change y with x and change every x with y. So whenever you see a y squared and a y, a light bulb should go off in your head. Your brain should say, oh, I gotta factor this. So let me try to factor this. 36, negative 12. What are factors of 36 that make negative 12? Negative 6 and negative 6. So I have x equals x minus, not x, excuse me. Let's try y. Y minus 6 squared. So now get y by itself. I'm going to square root. Y minus 6 is on the right, plus or minus the square root of x is on the left. So now I'm going to add 6 to both sides. That goes in the front. So I have 6 plus or minus the square root of x equals y. If I go over to number 16, change x with y and y with x. Now solve for x. Subtract 5 on both sides. So I have x minus 5 equals y squared. Square root. Y equals plus or minus the square root of x minus 5. Here's where it gets interesting. Let's see here. Let's try number 17. Change x with y and y with x. If I factor this, I get 6 and 5, so that's 3 and 2. Notice these don't match, which means it's not going to be a nice solving problem. So what do I do when factoring doesn't work? I can complete the square if I want to, but it's actually quicker to complete the square. In order to complete the square, my equation has to equal 0. So how I make this equal 0 is I subtract x on both sides. So I have y squared plus 5y plus 6 minus x equals 0. So now I'm going to write down a, b, and c so I have it. So a is 1 because a is always next to your variable squared. B is 5 because that's always next to just your variable. And c is 6 minus x because c is your constant, which is everything else. So now I'm going to take a, b, and c and plug into the quadratic formula. So the quadratic formula, the opposite of b, so negative 5 plus or minus the square root of b squared, which is 5, minus 4 times a, which is 1, times c, which is 6 minus x, all over 2 times a, which is 1. So clean up what I can. 5 squared is 25. 4 times 1 is 4. And 2 times 1 is 2. So now, if I look at this piece, I can go ahead and distribute. So I'm left with 25 minus 24, because negative 4 times 6 is negative 24. And negative 4 times negative x is positive 4x, all over 2. So just come over to this side. I have negative 5 plus or minus. 25 minus 24 is 1, plus 4x, all over 2. There's nothing else I can do. I'm done. So let's go ahead and do some function composition problems. So f of g of 2. So I have f of g of negative 2. So I'm going to evaluate g of negative 2 first. So I have negative 2 squared minus 2 times negative 2. Negative 2 squared is 4. Negative 2 and negative 2 make positive 4. That's 8. I'm now going to evaluate f of 8. So negative 5 times 8, that's going to be negative 40. If I do number 19, I have h of f of 4. So I'm going to do f of 4 first. So negative 5 times 4, which is negative 20. So I'm going to do h of that. So 2 times negative 20 minus 1. 2 times negative 20 is negative 40. Negative 40 minus 1 is negative 41. if I look at the next one, number 20, g of h of x. So I'm going to go ahead and plug in h of x into g of x. So if I just scooch this. So h of x, which is 2x minus 1, I'm going to plug that into g. So in g, every time I see an x, I plug in 2x minus 1. So 2x minus 1 squared minus 2x, which is 2x minus 1. So when you're squaring a binomial, that's essentially saying 2x minus 1 times 2x minus 1, which double distribute or FOIL is 4x squared minus 2x plus 1, and then I can go ahead and distribute that second piece, negative 2x plus 2. So I'm now just in one swoop going to combine everything. So 4x squared, negative 2, negative 4, negative 6, 1 and 2 make 3. Wait 1 second, I multiplied wrong. 2 times 2 is not 2. It would be 4. So it's not 6. It should be 8. Let's go ahead and keep going. Number 21, f of h, f plus h of 1. So I'm going to do f of 1 plus h of 1. So f of 1 is negative 5 times 1 plus h of 1, which is 2 times 1 minus 1. Negative 5 and 1 make negative 5. 2 and 1 make 2 minus 1, which is 1, which makes negative 4. G of x divided by h of x. G of x is x squared minus 2x over h of x, which is 2x minus 1. When you have subtraction signs or addition signs in a fraction, you can't cancel anything out. You're done. That's as far as you can go. The addition signs and the subtraction signs screw everything up. So if I take a look at 22, I'm going to do f of negative 4 times h of negative 4. So f of negative 4 is negative 5 times negative 4 times h of negative 4, which is 2 times negative 4 minus 1. So negative 5 and negative 4 make 20. 2 and negative 4 make negative 8 minus 1, which is negative 9. And 20 times negative 9 is negative 180. Ooh, how special. We have two number 22s. Let's do this 22. F of g of h of 2. So I want to do h of 2 first. So 2 times 2 minus 1, which is 4 minus 1, which is 3. So now I want to do g of 3, which is 3 squared minus 2 times 3, which is 9 minus 6, which is 3. And then I want to do f of 3, which is negative 5 times 3, which is negative 15. 23. I want to do f of x plus h of x minus g of x. F of x is negative 5x plus h of x is 2x minus 1 minus g of x, which is x squared minus 2x. Notice I put g of x in parentheses because when you subtract, you have to put it in parentheses so your brain remembers to distribute that negative to everything you're subtracting. So it's going to be negative 5x plus 2x minus 1 minus x squared plus 2x. So, if I combine like terms, I have negative x squared, negative 5 and 2 make negative 3, negative 3 and 2 make negative 1x, which is just negative x, and then minus 1. Using function composition, prove the following statements are inverses of each other. So I need to prove v of m of t equals t, and then I need to prove m of v of t equals t. So m of t is 2t plus 14. I'm going to plug that into v. So 1/2 times 2t plus 14 minus 7. So I have t plus 7 minus 7, because I distributed 1/2, is left with t. So that matches. So now let me try the other side. b of t is 1/2 t minus 7, and I want to plug that into m. So 2 times 1/2 t minus 7 plus 14. Distribute, I'm left with t minus 14 plus 14, which equals t. So yes, this, ooh, whoa, don't know what happened there. Let's zoom out. So this and this are inverses of each other, so I'm good to go. Evaluating piecewise functions. R of 1, I'm going to plug R of 1, I'm going to plug 1 into my top equation because 1 is in between that inequality. So negative 5 times 1 is negative 5. I'm going to plug R of 10 into the body equation because 10 is equal to 10, which is the bottom equation. So I have the square root of 10, which is just, not that. Let's try that. How about the square root of 10? If I look at R of 2, I'm going to plug that into my second equation because 2 is equal to 2. So I'm left with the square root of 2. If I look at number 26, R of 0, 0 would be in the second equation. So since y is negative 4, when it's 0, it's still going to be negative 4. When j is 5, and these x's should have actually been, no they're not, there should have been x's. So with 5, I'm going to also plug it into my second equation because 5 is greater than negative 4. So it's going to stay negative 4 and negative 4. I'm plugging that into my top equation because it's equal to negative 4. So I have negative 2 minus negative 4, which is negative 2 plus 4, which is 2. So now I need to go ahead and graph this piecewise function. So x plus 4. So x plus 4, 1, 2, 3, 4. Up 1 over 1, up 1 over 1. Just keep graphing. So now let's set my bounds. It's less than or equal to 3. Oh, perfect. So 3 is right here, and it's going to be a closed dot. And going to the left. Now if I do negative 2x, 1, 2, 1, 2, 2 over 1. It's going to be greater than 3. So at 3, it's going to be an open dot, and it's going to be going that way, which means I can erase all those extra blue dots in my problem. If I do the next one, y equals 1 at less than -2. So it's going to be a closed dot going that way. So now if I graph 2x plus 1, so here's 1, up 2 over 1, up 2 over 1. I'm going from -2 to 2, so I just did +2, so now I got to get down to -2. And at -2, it's going to be an open dot. And at +2, it's going to be a closed dot. And then I'm going to connect them. And, oops, let's use the highlighter tool. 3x minus 2. So if I plot that there, I'm going to go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'm going everywhere that's greater than 2. So I can erase all of these. And at 2, it's going to be an open dot going in that direction. Hopefully your lines look a little prettier than mine. Last one. Given the following graph, determine the piecewise equation. So, all right. So I know it's just going to be f of x. You can pick any letter you want. It's going to look like this. So if I look at this equation, or this line, I know it's a Hoy line at -4. And my restriction is when x is less than -2. I'm going to now do this line where my slope is 1, 2, 1, 2, which 2 over 2, which is just 1, and my y-intercept is 0. So my equation is just x, and my restriction is -2, which is less than or equal to x, which is less than or equal to +2. If I look at my last line, let me not do red, let's do yellow. I first have to find my slope, so then I can find my y-intercept. So 1, 2, 3, 1, 2, 3. So that's still 1 over 1, essentially. So, and notice it's in the middle, which would mean 1. Up 1 over 1, up 1 over 1, up 1 over 1. Yep. So down 1 over 1, down 1 over 1. So my y-intercept is going to be right there, which is -1. So I have x minus 1 when my bound x is greater than 2.